Today we're going to look at probability with a different type of diagram. But we're going to relate it to what we've already seen. So if you've gotten your new notebook, the blue spiral notebook, please make sure that the substitute teacher gives you one. I just want you to open up to page 3. And you'll see the new type of diagram we're going to use. It's called a tree diagram. Looks like this. And we're going to be able to find probabilities from this tree diagram by relating it to what we've already seen. Venn diagrams, we've seen those in the past couple of days, as well as two-way diagrams, two-way tables that you've seen last year. These are the different types that you can use. We've redrawn the diagram from your book in a couple different ways. This is the way we've used most recently, a Venn diagram. We have the same information on this diagram that's on the tree diagram, and we'll be able to write probabilities using either one of these. Same is true for the two-way table. Same information that's on this diagram is on the two-way table, and the same information that are both of these are also on the tree diagram. So let's see an example of that. This is the one we're most familiar with. We've done it recently. So this tells us, based on this sentence here, that this tree diagram represents data of 1,000 people who have been given a skin test for tuberculosis. According to this tree, there are people that have tuberculosis, that have TB, and there are people that do not have TB. On our diagram, the people that have TB are inside of this circle, inside of the TB circle. On the diagram, on the tree diagram, it says that 380 people have TB. But do we have 380 people inside of this circle? Well, we do if we add up everybody inside of the circle, everyone. These 19 and these 361. Remember, this region inside is called the intersection. So the people that are in this intersection not only have tuberculosis, but they have a positive test. They're in the positive circle. That's also shown on this two-way table. There are 361 people in fact, that are in the intersection because they're in the TB circle and they're also in the positive, the circle for people who've tested positive. In other words, if we look on our two-way table, we have people who've tested positive. They're in this column. This is the positive column. And they're in the TB row, this row. So if we look at everybody who's in this row and in this column, we'll be left with just the people in this square, 361. This diagram shows the same thing that our table does. This is the intersection. We also call this a joint frequency because it's where this column and this row are joined or intersected. We use that word intersection when we describe this region in this lens-shaped region in the Venn diagram as well. We can also, from this table, find our conditional probabilities. Remember that a conditional probability looks something like this. It has a symbol that we use for a condition. For instance, we might want to ask, you'll be asked to do this in a few minutes, you might want to ask, what's the probability that someone has TB? You want to write this symbolically. Given the fact that they have a positive test result. Again, this is read as the probability that someone randomly chosen here has tuberculosis, given the fact that they have a positive test result. So to find this out, to determine what this probability is, they said to use the numbers that are on here in your book. In your book it says use the information from the numbers provided. So we'll look at the people we want to consider only, or we want to consider that we're only going to be given the people who are positive, who have tested positive. And we could tell that from two things here, from our table or from the Venn diagram. So if we look at the people who have tested positive, it's just these 423 people. Everybody in this row has tested positive. So our sample space will be 423 people. But of those 423, we're only considering or given these 423. Of those 423, we'll want to find out how many have tuberculosis. Well, of the people that are in this column, only these 361 have tuberculosis. So let's fit this on one page. Our probability, our conditional probability, you're going to be asked to write several of these, will be the number of successes that we have, 361, out of our sample space, 423. You don't have to reduce these today. So this will be 361 out of 423. That's one of the types of probabilities that your book is going to ask you to write. You can also write unconditional probabilities where we don't have a bar here. For instance, we could ask the probability that somebody has TB, has tuberculosis. And to find that, we can look at either this Venn diagram or the table or the tree diagram. We'll do all three. So the probability that someone has tuberculosis from the Venn diagram is going to be the people that are inside of the tuberculosis circle, the TB circle, divided by how many people we have all together. So if we add up all three of these, and plus they've told us, we have 1,000 people. If you add up 19 and 361 and 62 and 558, we'll have 1,000 people. Again, that was also given to us right here. But we want to know, of those 1,000 people, how many have tuberculosis? Well, there's a couple ways to find out. One way is by looking at this diagram. In this circle, there are 19 people that are in this crescent region, plus 361 in the lens region. And if we add those up, we'll get 380. Today, you don't have to reduce this. You don't have to simplify it. It's good practice, huh? So the probability that someone has tuberculosis is these 380 people out of all of these numbers. If we add them together, is 1,000 people. We can do the same thing, and I'm not going to write the answer here. I want you to find it. If we want the probability that someone tests positive. But let's go back to this one for a second. We said that we could find it using either this diagram, this Venn diagram, or the table, or the tree diagram. Well, we should get the same answer, 380 over 1,000. If we use the table, and we want the probability that someone has tuberculosis, we have to look in the row that has tuberculosis. There are some people that have tuberculosis that test positive. There are some people that have tuberculosis that test negative. But if you add those up, you get all 380 people that have tuberculosis. But that's just going to be our denominator. We already saw that. There it is. But that's our numerator. But our denominator is how many total people in our sample space, which is 1,000. All the information that we need is already on this chart. So I'm going to fold this over again. So in this case, still, we get the same answer. The probability that somebody has tuberculosis is somebody in this row, 380 people in this row. Out of all the people that they've surveyed or that they've tested, out of 1,000, our probability is still 380 out of 1,000. We could find the same information by looking at our tree diagram. If we want to find the probability that someone has tuberculosis, we look at this number divided by the total number, the sample space. So all three of these diagrams can be used to write and to find probabilities, and that's what you're going to be asked to do in this section.